Hi everyone, this is your instructor Alina Sheikh, and today I'll be starting with activity 10.2. And the question is activity 1, and the question is produce truth tables from the following logic circuits. The logic circuits are given, and now you have to produce a truth table. And what is actually the truth table? It is the truth table. The truth table basically it shows all the inputs and the associated outputs with it. We have the inputs as well as the outputs. So first of all, for the to make the truth table, we should know that what are these gates so that we can just write the output. We know that this is AND gate, this is OR gate, this is NOT gate, and this is OR gate. We have identified the gates. The second step is to see that what are the inputs to the gate. For example, if this is AND gate, this is AND gate, and the inputs to this gate are A and then B. We can make a dot and then we can carry it anywhere like B, and then I can just carry it over B, and it is the input to AND. Then I have OR gate. The inputs to this gate is A and B. Then whatever it is the output of OR gate, it is the input to NOT gate. Then we have the OR gate. Since it is a two input gate, it has the output of AND gate and the output of NOT gate as its input. This is the final output. Okay, so let's make a truth table. So first of all, I have written the inputs, that's A and B. So I have filled in with the inputs. Now let's see that this is AND gate. Now I will write P here. I will just give this variable at I have written this variable, and this variable is basically the output of AND gate. Whatever the A and B is the input, and then this is the working that all I will be doing. This is P. I have given the name P. Whatever the output is of AND gate, this is known as P. So AND gate I just wrote here P. Okay, and since it is an AND gate means if both the conditions are true, the output is true. It means that if both the conditions are 1, if both the inputs are 1, the output is 1. Otherwise, it's 0. Okay, now let's consider the next one, that's OR gate. For the OR gate, I have two inputs, that's A and B. Okay, so I'll write the output here. For example, if I write Q, whatever of the output of OR gate, I'll consider it as Q. Then this Q, and this is OR gate. OR gate, the condition for OR gate, we have the two inputs, that's A and B, and P is not our input. Okay, that's A and B, it's the input to OR gate, and the output is Q. So I'll write 0 here, then I have 1 because there are 0, 1. If at least one condition is true, the output to the OR gate is 1. It is true. And if both of them, then it's also 1. The output is 1. Now I have these two inputs. Now let's see that this is Q and this is the input to NOT gate. NOT gate, I'll write R here. Then the input to the NOT gate is Q. So what I will do, I will write an output here. That's R. The input is Q. See, Q is the input to NOT gate. So this is the input, and here I'll write the output. NOT gate, whatever we give this signal, it gives the opposite signal. For example, if we write 1, it will give us 0, and if I write 0, it will give us 1. Now see that this is OR gate, and what are the inputs to OR gate? That is P and R. These both are the inputs to OR gate, and the output is X. So P and R, these are the inputs to OR gate. So what I'll be doing, I will just put eraser here so that there's no confusion. And since it is an OR gate, so P and R, this is 1 0 0 1. So this is part A of activity 10.2 question number 1. Now let's start with part B. Here you go with part B. First of all, I'll write all the inputs. I will see that names of the gates. Okay, I'll write all the names of the gates. I'll identify the gates and then write them. This is NOT gate, this is OR gate, this is AND gate, this is NOT gate, and this is NOR gate. Yes, this is NOR gate. So what I'll be doing, first of all, I'll see that NOT gate has only one input. It always has one input. So A is the input to NOT gate, and whatever the output will come, I'll name it as P. And OR gate has two inputs. That is A and B. So first of all, let's write P. Since NOT gate has one input, that is A, and I have named the output as P. So I'll write the outputs here. Okay, I'm done with the outputs of NOT gate, and now let's see the OR gate. Okay, A and B. These are the two inputs to OR gate. I'll write Q here, PQ. So OR gate, the inputs are A and B. The inputs are A and B. So OR gate, this is 0, this is 1, 1, 1. Okay, now we are done with PQ. Now let's see that this is the not, sorry, we are here on this. Okay, we have written P and Q, and this is AND gate. AND gate, the inputs to AND gate are P and Q. So what I will work with these two inputs, and then AND gate, I'll name it as Q, PQ, R. Okay, R, this is the output of AND gate. These are the two inputs. P and Q are inputs, and R is the output. So I'll write R here, PQR, and this is AND gate. So 0, 1, 0, 0. And now I'll just write PQRS because this is NOT gate. R is passing through NOT gate. Then I have S. Here I have S. R is passing through NOT gate. So all the inputs will be the opposite. Now this is NOR gate and the output is X. Now let's trace that what is the input to this gate. Here you go. This Q is the input and here it is S. So we have S and Q as the inputs to NOR gate. So S and Q, these are the inputs to the NOR gate. NOR gate is the opposite of OR gate. So it means that 0, 0, 0, 0. This is our part B. Now let's have a look at part C. For part C, I have this gate, that's OR gate, that's NAND gate. Here we have XOR gate and this is OR gate. Now since I have identified the gates, and now what is the thing that I'll be gonna doing? I will just identify what are the inputs to this gates. For example, for the OR gate we have inputs A, B. For the NAND gate we have inputs B and C. Now let's write P here and I'll write Q here. The inputs to the OR gate are A and B and the output is P. This is OR gate. I'll write the inputs for part C, and we have three inputs, that's A, B and C. So I'll write 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and that's 1, 1, 1. We have 8 combinations. Let's count 1, 2, 3, 4, 5, 6, 7, 8. We have 8 combinations. And now let's write P here. Since A, B ORed, and then we have the output P. So A and B, they are ORed. 0, 0. We have 1 here. 1, 1, 1, 1, 1. Like everything is 1. Now we'll write Q because we have named it as Q. B and C, there are NAND. This is NAND gate. B and C NAND, and then Q. So B and C will be working with B and C NAND. For the NAND gate, it is the opposite of AND gate. Okay, so NAND gate is the opposite of NAND gate is the opposite of AND gate. I'll write 1 here, 0, and then 1. Yes, 1, 1, 0. Now let's see. This is XOR gate. The inputs to XOR gate are P and Q. So for the XOR gate, I'll write PQRR. Okay, so this is R. There you go. So P and Q, these are the inputs to XOR gate. I'll write R as the output. So XOR gate, what is the condition of XOR gate? If two inputs are same, the output will be 0. So here we have two inputs as the same. Otherwise, it will be 1. PQR. R के बाद we have this gate, that's X, the final root gate. The output. Okay, so what are the inputs to this OR gate? We have this R, and then trace back. Let's trace back. This is C. R and C are the inputs to OR gate. So R and C, this and this, these are the inputs to OR gate. So R and C. Here we have 1. Here we have 1, 0, 1. 0, 0, 0, at least 1, so we'll write 1, then 0, and then at least 1 we'll write 1. So this is the answer of part C. Now let's start with part D. So here you go with part D. For the part D's, first of all, let's identify the gates, the names of the gates. Let's write them down. This is OR gate. This is OR gate. In the very first lecture, I told you should know the name of the gates, how to make the truth table for the gates, and also the function of the gates. So, and this is the NAND gate, and this is also XOR gate. So that's P. I'll write P. The inputs to the XOR gate are A and B. So P is the output. XOR gate, the condition for XOR gate is that if two inputs are the same, these are the two inputs, if they are the same, the output will be 0, otherwise it's gonna be 1. Now let's consider the second one. That's P, and now you have Q. For Q, this is C, this is the input, and for OR gate, this is the input, and then you have this dot over here, and you are dragging it here. So A and C, these are the inputs to the OR gate. To OR gate, we have two inputs, that's A and C, not B. This is not B. This is ORed with C, or A is ORed with C. Okay, so A and C, they are ORed. So I'll write Q here as the output. A and C, these two are ORed. So let's write down 0, 1, A and A or C, A or C, A or C, A or C. At least if there is a 1 in the inputs, we'll write as 1. Now let's see that we have two inputs, P and Q, to NAND gate, and I'll write the output as R. So P and Q, these are the inputs to NAND gate. Let's write R here. The inputs to NAND gate are P and Q. NAND gate is the opposite of AND gate. So here we write 0. When both of them are 1, we write 0 in NAND gate. Otherwise, we write 1. Then now this is an R and C. These are the inputs to XOR gate. So output is X. R and C, these are the inputs to XOR gate. R and C, this and this. These both are the input to XOR gate. For the XOR gate, what's the condition? If both of the inputs are 0, or if both of the inputs are 1, the output is 0. It means if both of the inputs are same, the output is 0. Here we have 1. This is 0 because both of the inputs are same. And then, we have the 1. Then C and R, C is or R. These, both of them are different, so it's 1. Both of them are same, the output is 0. Both of them are different, the output is 1. The output is 1. Both of them are same, the output is 0. So here you go with part D. That's the answer. Now let's have a look at part E. First of all, let's identify the gates. This is OR gate. This is NOT gate. This is NOR gate. This is XOR gate. This is XOR gate. Now A and B, these are the inputs to OR gate. This is P, the output is P. So first of all, let's write the inputs. Part A, B, and C. These are the inputs. So what I'm doing, I am writing all the inputs. So to further recheck that if I've written it correct, or just to confirm that since I have 3 inputs, and then I should have 8 combinations. That's 1, 2, 3, 4, 5, 6, 7, 8. I have 8 combinations. Okay, I'm correct. I'm on the right track. So this is the output P, and that's A or B. A or B अगर हमने लिखा, तो the output, we have the output as P. A or B, यहाँ पे हम लिखेंगे 0, since A और B से हमें काम है ना. A और B, बाकी जगह हमने लिख दिया 1 because at least एक भी 1 होगा inputs में, the output will be 1. P हो गया, and now let's कौन सा था, ये वाला part था. So now P के बाद हम इसको Q कर लेते हैं, and P is passing through NOT gate. So I'll write Q here, and here you go. NOT gate में whatever the input is, we'll write the opposite of input for the output. P, Q, and then R लिख देते हैं यहाँ पे. अब इसके inputs क्या है NOR gate के we have B and C. These are the 2 inputs to NOR gate. We have 2 inputs, that's B and C, और वो NOR gate है, और हमने output लिखा R. So inputs से B or C. NOR gate is the opposite of OR gate. So B or C, these both are the inputs to NOR gate and the output is out. B और C से हमारा काम है. तो NOR gate is the opposite of OR gate. हमने क्या करना है, यहाँ पे 1 लिखा, यहाँ पे 0 लिखा, 0 1 0. जहाँ पे 2 zeros होंगे ना, उधर हमने 1 लिखना है और बाकी जगह पे हम लिखेंगे 0. 2 zeros होंगे NOR गेट में, 2 zeros हैं तो हमने 1 लिखना है. अब यहाँ पे देखें, सो वी हैव दिस XOR गेट. Q and R, these are the inputs to XOR gate, and now I'll write the PQRS. XOR gate, Q and R are the inputs, S and Q and R are the inputs. These both are the inputs to XOR gate and the output is S. So what I'll be doing, this is XOR gate. For the XOR gate, if two inputs are same, the output is 0, otherwise it's 1. 1, then I have 0 0 0. Okay, now see, this is also XOR gate, but the inputs here are S and then we have C. These two are the inputs to this XOR gate, because you can trace this back. Here you go. Okay, so these S and C, these are the inputs, so I'll write the output here as X. And we have XOR gate, the inputs are S and C, this and this. These both are the inputs. अब XOR gate है, XOR gate में क्या होता है, if both the inputs are same, the output is 0 0, again 0, then 1, this is 1, this is 1, this is 0, because both the inputs are same. So here you go. So this was activity 10.2, sorry, activity 10.2, question number 1. In the next class, we'll be starting with question number 2. Till then, take care of yourself and subscribe to my YouTube channel. Thank you so much for watching.